Section 5.4, question number 6. Tangent of some angle theta is 8/6. And theta is somewhere between 0 and pi over 2. What is the sine, cosine, and the secant? What do we do first? We draw a picture. So we could start with the whole circle. And my preference is to draw the unit circle, but you could draw any circle you wish. So let's see, how about a green circle? Let's see if I can do good. Not bad. All right, 0 to 2 pi, so that puts me in the first quadrant here, right? This is 0 radians over here. And sorry, not 2 pi, pi over 2 radians is up here. So I'm somewhere in this quadrant here. And then tangent. Okay, what do I know about tangent? I know that the tangent of theta is the y value of a point on the unit circle divided by the x value. I also know it's the slope. So here I can say I have a slope of 8/6. Now that reduces a little bit. So let's think about slope of 8/6. 2 divides top and bottom. So I could say that would be 4/3. So up 4, right 3. Let's see, let's suppose like that would be a half right there. And then this would be a quarter there and there. And so if I count by quarters, I would go up 1, 2, 3, 4 quarters, and then right 1, 2, 3 quarters. So that would put me up here somewhere. And so this is a slope of 8/6 or 4/3. So I just did my best line, m equals 8/6, oops, or 4/3. And I want to be in a unit circle. I like unit circles best. So I'm going to put a 1 there and there. So that's my line right there. And I rewrote that slope right there by saying I was working, let's see. Yeah, I went up 4, right 3. That works fine. So I have this triangle right here based on that point up there. This is the point I'm really concerned about right there. And let's say, I'm going to rewrite that as follows. Let's call that, no, we're just going to go for it. So I'm going to off to the side, draw another triangle. It looks like that-ish. I'm going to call that the up 4, right, my rise. I'm going to call this the 3, my run for my slope. And then I need to figure out what the hypotenuse is. Sure. Pythagorean theorem says 3 squared plus 4 squared has to equal question mark squared. So 9 plus 16 is equal to question mark squared. And so let's see, 9 and 16 on a good day is 25. Ooh, that's nice. So I get question mark squared is 25, take the square root, question mark has to be plus or minus 5. Since that's, I'm looking at that as the hypotenuse or the radius here, I'm just going to call it 5. R or H for hypotenuse is 5. So I have that triangle. I'm just going to redraw it down here for a second, it's a little bigger. And I was saying this is 5, if that is 4, and that is 3 right there. And I'm just going to rescale this to be a radius of 1, right? But I want that same angle theta down here. So if I rescale that for a radius of 1, to turn 5 into 1, I just divide everything by 5. And I'm just going to do that because then I can identify something on the unit circle here. So dividing everything by 5, I get that, which puts me now on the unit circle. So that means the y value that I traced out here is going to be 4/5, and the x value down here is going to be 3/5. And so now I can name all of these over here. So the y value has to be 4/5. That's not a very good looking 4/5. Let's make a better slash. There we go. Cosine is the x value, so that has to be 3/5. And the secant, remember, flips the cosine. And so that's going to be 5/3. All right, was there an easier way to do this? The answer is, I'm thinking of one right now. Yes, there is. My desire to always work on the unit circle isn't always the best idea, but it always works. I could have instead done the following. Let's see, new page, but I want to copy that picture. So instead of the unit circle, I could have just gone with a general circle of radius r. So if I do it that way, starting with a circle, centered at the origin, and I want a point on that circle where, and again, oops, a pen, 8/6 can be reduced. So I think it's a good idea to reduce things when you can. So 2 goes into 8 4 times, and 2 goes into 6 3 times. So I like the 4/3 better. Tangent, again, is y over x. So I want to find a point on that circle there where I go up 4 and right 3. So again, we have to decide what up 4 means. So I'm just going to make some kind of arbitrary measure here. And the easiest thing that comes to mind really is to cut this into 4 chunks, but 4 equal chunks, up 4 and then right 3. I want to proceed that same way here. So it's kind of the way I did it before. And then if I trace that 3 over and that 4 over, again, there's my point right there. So I got to know tangent is y over x, or that it's the slope of a line, slope of a radius. So here's that line right there. And let's see. So that point right there, I'm going to claim is the point x equals 3, y equals 4. And I've made a right triangle here. I just need to figure out what r is to that point up there. And so like before, 3 squared plus 4 squared, yeah, this isn't really much different than I did before, equals r squared. 9 plus 16 is 25. So then r has to be the square root of 25, which is 5. So to get to that point up there, I want a radius of 5. So that gives me a slightly bigger circle than I drew the first time. This circle out here is my circle. And so here I'm claiming that, again, x is 3, y is 4, and r is 5. Whereas the last time I did it, I was working with fractions. Right? This was my y and that was my x. But I had to draw a second circle to get there. So is this much easier? I guess not really. Sine is the y value divided by the radius. And so that's going to give me 4/5. Cosine is x divided by the radius. So that's going to give me 3/5. And the secant is the reciprocal of the cosine, which is the radius divided by x. So that would be 5/3. All right, same thing I had before. So here I had to draw 2 circles to get the graph to match up. And over here, I had to play with the triangle to get a radius of 1. Okay, so maybe this one was slightly easier with that in mind. What's the important part here? Draw a picture, draw a picture, draw a picture. And if you forget the first three rules, draw a picture.